Okay, so in this worksheet, we are going to solve a problem on charging objects. So here the diagram below shows the initial charge and the position of three identical metal spheres, X, Y, and Z on insulating stands. So these are insulating stands. And the charge on the X is positive plus 4 times 10 to the power negative 6 coulomb. Y is 0 and Z is also 0. Then it says if we read ahead, sphere X is with a charge of plus 4 times 10 to the power negative 6 coulomb is brought in contact with a neutral sphere Y. So X is brought in contact with Y and then removed. So when you touch X with Y, X is having some charge and Y is neutral. So they are going to share the charge. Each one of them will become 2 times 10 to the power negative 6 coulomb because they are going to share the charge. So after touching, let's draw it here. We have got X and Y, and each one of them will get 2 times 10 to the power negative 6 coulomb here, and this one also gets 2 times 10 to the power negative 6 coulomb. So that's your X and Y. Then it says the sphere Y, then sphere Y is brought in contact with another neutral sphere Z and removed. So now you take this Y, which you have given 2 times 10 to the power negative 6 coulomb, and take it and touch it to Z, which is 0 coulomb. So again the same thing will happen. Y and Z will share their charges. So Y, which was having 2 times 10 to the power negative 6 coulomb, it will share its charge with Z, which is neutral. So you will get 1 times 10 to the power of negative 6 coulomb on each one of the objects. Then it says complete the table below indicating the charge on each of the spheres after the procedure is completed. So we can just fill in the numbers here. X will have 2 times 10 to the power negative 6 coulomb. Y will have 1 times 10 to the power negative 6 coulomb, and Z will also have 1 times 10 to the power of negative 6 coulomb. That's how we can solve this problem on charging objects. Next question is on quantization of charge. A strong lightning bolt transfers 25 coulomb, about 25 coulomb to earth. So that's the value for charge given. We can write that as Q is equal to 25 coulomb. Then it says how many electrons. So let's just highlight that. How many electrons are transferred? How many? That means it's asking for the number of electrons. What does this mean? It's asking what is the number of electrons. That means it's asking for the n. N equal how much? So we are going to use the formula for quantization, which is Q equal Ne, where N is the number of electrons and E is elementary charge, which is a constant, and it will be provided in the exam. So 1.6 times 10 to the power negative 19, that's the value for E. So let's just substitute 25 equal 1.6 times 10 to the power of negative 19 and the n, so I have to write n also. So let me just move this to the side. Let's bring the n here. N times 10 to the 1.6 times 10 to the power negative 19. Now we can solve n. So we'll get that as we'll rearrange the equation. 25 divided by 1.6 times 10 to the power of negative 19, and we can solve it using our calculator. Okay. So I've got my calculator. That's 25 over 1.6 times 10 to the power of negative 19, and that gives me the answer as 1.56 times 10 to the power of 20. So you can see it's a positive power. That means this is an integer. 1.56, and then if you put 20 zeros after it, it will become an integer. That means this is an allowed number, so these many electrons are transferred.